Go.
Today, Ian and Brett will be describing our problem for homework number 2, problem 7. We will begin with an explanation of the problem. So we have two beams. Beam 1 is just a solid beam with a single flexibility, and beam 2 is comprised of two different materials with different flexibilities. And as you can see on the left, that the force being applied is on a track, which keeps the force uniform. And now we want to solve for the total displacement of the beams, and since they are on the track, the displacement will be the same for both of the beams. So first let's start with the force balance. And we have the force 1 plus the force 2 in the middle of the beams on the right hand side there together, equaling the negative reaction at A minus the reaction at B. Now we'll go on to the force displacement, which gives us the equations for delta. So delta 1 is equal to the flexibility times the reaction force A. Delta 2 is equal to the flexibility at portion 2 times the force of 1, which is then equal to the flexibility at 1, that's a 1, flexibility 2, and that's from the force balance equations. We also get that the displacement at 2 is equal to the flexibility of 2 minus times the negative of force 2 minus the reaction at B. And now for the third displacement is just the flexibility multiplied by RB. So now I go up to the compatibility of the force balance and the displacements. And so that is related through the displacements of each of the beams, where the displacement of the beam on the right comprised of beam 1 comprised of two beams, the sum of those is equal to delta, where the beam on the left and the beam on the right have the same displacements. So now we want to combine equations 2A through C with equation 3 from the compatibility, and we can arrive to something where solving for RA equaling its displacement over the flexibility 1. And now from the displacement 2 plus displacement 3, we can substitute and get flexibility 2 times the sum of the difference of negative F2 minus RB plus flexibility 3 times RB. Our goal is to find RB independently, equaling delta. From there, algebra reveals that the negative flexibility of 2 times the force 2 plus RB, combining like terms, times force 3 minus force 2, or flexibility 3 minus flexibility 2, equaling delta. And then RB is now revealed to be delta plus flexibility 2 times force 2, all over the quantity F3 minus F2. Now going back to the force balance equation and substituting these in, we get that the force 1 plus force 2 is equal to negative delta over flexibility 1 minus RB, which is then delta plus flexibility 2 times force 2 over the quantity flexibility 3 minus flexibility 2. After much algebra, we can find that the displacement is then equal to the force 1 times the flexibility 1 times the quantity flexibility 3 minus flexibility 2 plus the force 2 times flexibility 1 times flexibility 3 all over the quantity flexibility 2 minus flexibility 3 minus flexibility 1. And there is your equation for displacement.